The first type of chemical bond we're going to talk about is going to be the ionic bond. Now, an ionic bond is going to be between a metal and a nonmetal. The metal is going to lose electrons, and the nonmetal is going to gain electrons. In this case, I'm going to form an ionic bond between a sodium atom, which has an atomic number of 11, and a chlorine atom, which has an atomic number of 17. And we're going to form an ionic compound called sodium chloride. Sodium chloride, because of this chemical bonding process, is going to have completely different properties than either of the elements that it was made from. I've also drawn the two atoms on the board, the atomic structure here. Sodium, because it has an atomic number of 11, it's got 11 protons. And an electrically neutral sodium atom is also going to have 11 electrons. So 2 of those electrons are going to be in the first orbit, 8 are going to be in the second orbit, and the last of the electrons is going to be in the outermost orbit here, or valence orbit. So sodium has 1 electron in its valence orbit. Now sodium, as well as all atoms, want to do the simplest thing they can possibly do. And that's nice because that makes atoms predictable. If we know that they're going to do the simplest possible thing, then we can predict what they're going to do. So sodium has 2 options here. In order to fill its outermost orbit, it can either lose this 1 electron, in which case this then becomes the outermost orbit. So it can lose that 1 electron, or it can gain 7 more electrons, in which case this would be the valence orbit. So sodium wants to do the simplest thing possible, so it's going to choose to lose this 1 electron. We also have chlorine over here, and chlorine has an atomic number of 17. So chlorine has 17 protons in its nucleus, and an electrically neutral chlorine atom will have 17 electrons. There's going to be 2 electrons in the first orbit, 8 electrons in the second orbit, and 7 electrons in its valence orbit. And again, chlorine is going to do the simplest thing possible. So chlorine has 2 choices. It can either gain 1 electron to fill its outermost orbit, or it can lose 7 electrons, in which case this becomes its outermost orbit. So we know that atoms are going to do the simplest possible thing, so chlorine is going to choose to gain 1 electron if at all possible. Now the nice thing here is that we've got 1 atom willing to lose 1 electron and 1 atom willing to gain 1 electron. Sodium, in order to lose this 1 electron, has to have another atom to give that electron to. It just can't throw that atom into space. So we've got a win-win situation here. 1 atom wants to lose an electron, 1 atom wants to gain an electron. And that's exactly what's going to happen here. This 1 electron is going to lose, or this electron is going to move over to the chlorine atom and become part of it. So we'll go ahead and we'll draw that electron in there. And I'm going to erase that electron, and in fact I'm going to erase this entire orbit right here because it no longer exists. Now let's do just a little bit of math here. The sodium atom still has 11 protons in its nucleus. However, it used to have 11 electrons, but it lost 1 electron, so it only has 10 electrons now. And if we do the math, we've got 11 positives, 10 negatives. We're going to come up with 1 positive. That's going to be the difference. So sodium now has a +1 charge, and we're going to call that an ion. An ion is an atom that has gained or lost electrons. So our sodium ion has a +1 charge. Now chlorine still has 17 protons in its nucleus, and it used to have 17 electrons moving around its nucleus, but because it gained an electron, it now has 18 electrons. And if we do the math, overall we're going to have 1 more electron than we have protons, so we're going to acquire a -1 charge. And chlorine, because of this, also is now called an ion, a chlorine ion. So we've got a +1 charge on sodium ion, a -1 charge on our chlorine ion, and in chemistry we like to say opposites attract. So these two oppositely charged ions are going to attract each other. And this electrical attraction that occurs between these two ions is called an ionic bond. And this ionic bond is going to be a very strong bond, but it has its Achilles heel, and its Achilles heel is going to be water, and we'll talk about that later.